Now, h differs from 0 tells us, because the points A, B and C are all different, h differs from 0 tells us that A does not lie on Q. But since E only occurs in connection with B and C, we now characterize Q as the line through B and C. And h differs from 0, we now formulate as triangle EBC is not degenerate. But if triangle EBC is not degenerate, hence BC is actually less than BE plus EC. The triangular inequality, that the sum of two sides is larger than the sum of and then the third side.
And then you have to take A between these.
I don't know. I don't know.
Then AB,
Sorry, no.
then AB plus AC is equal to BC.
I'm looking at this. And on account of monopolicity, I conclude that this follows from AB plus AC is at most BC. Yeah? From monotonicity.
If you have 2 points
From this. Huh?
if you have 2 points BC and A is very far away, the old A.
I'm a minute. But for this transformation, replacing this by the smaller BC, I don't need to take A into account. You are rushing ahead. Your conclusion is correct. Again, on account of the triangular inequality, AB plus AC is at least BC. Hence, this is equivalent to AB plus AC equals BC. Yeah? And these are all non-negative, all positive distances. And the only way in which this can be is if A lies between B and C. So we have concluded that it is okay with A between B and C. Of course, this is the only symmetric choice, so it's not surprising. But what is charming is that that fact is forced upon us by the calculation that shows that the minimum of little b and c is less than h. End of proof. Why is this very nice? You see, if you compare it with Kelly's proof, that contains the same element. Kelly says, well, consider all lines and all possible combinations for Q and E. There's all possible pairs of a line and a point not on that line. Finite collection, at least one such pair contains the minimum distance. Yeah? And then he says, well, okay, suppose that, of course, Kelly in 1948 proved it by a contradiction. So immediately it says, suppose that there are 3 points on the line Q, and then he derives a contradiction. We don't need to do that. Now, at the time, Kelly's introduction of the Euclidean distance was greeted as a great invention, original idea that only a genius can have, because of course it is a foreign element, because the problem statement itself has nothing to do with Euclidean metric. It's, the theorem is affine invariant. So it is a foreign element. But we know that given a program with a repetition, we know that whereas the invariant of a repetition is uniquely determined by the program itself, the variant function, the decreasing thing that one invents to prove the termination argument, that's not determined at all. If you have some function t that decreases, any monotonic function of it will do it as well, of t will do it as well. So we know that if in arguments like that any inventiveness is required, it is at the choice of the variant function. Now I have taken extensive experiments with this problem at oral examinations, and I have also shown this a number of times lecturing to an audience. At the critical moment that the Euclidean distance between Q and E has to be invented, it has always been the audience that supplied this foreign body to the argument. In short, as soon as you regard this as a programming exercise, Kelly's invention becomes the most natural thing to do. So there has been progress. As a final mark of progress, I would like to read to you, because it's a little bit long to write down, Sylvester's original statement of the problem. And that will give you another aspect of progress in a century of mathematics. Prove that it is not possible to arrange any finite number of real points so that a right line through every 2 of them shall pass through a third unless they all lie in the same right line. When I tried to read that, I discovered that I couldn't. There were too many negations and unlesses, etc. And in utter despair, finally, I took the Concise Oxford Dictionary, because I now wanted to know very precisely what unless means. Yeah? Now, I'm a modest man and I'm not afraid of going to the authorities. It was very illuminating, because the COD gives 2 meanings for unless. And the one is if not. Now, if is the follows from, and not is the negation. This is or. And the other one it gives is except when. And if you start analyzing what except when means, then you will come to not equivalent. So even the statement of the theorem is already ambiguous.